Welcome back to the Coke Academy. Today's objective is to learn about negative bases when we're working with powers, to apply index or exponent laws to simplify powers, and to use our calculators to solve exponential expressions. You will need, for this class, for this video, you will need the handout titled Chapter 2, Indices, Day 2. Please follow along and take notes on your packet as you watch the video. You also should be pausing your video at appropriate moments to work on problems. And whenever I suggest you do that, please do pause it, work through the problems, and then you can turn it back on to check your work. So let's go into full screen for this. And that go away. Okay, so there's our objectives for today. And you will need to finish the handout. There are lots of problems in the handout that you can work on to practice when you're finished watching the video. Okay, so first of all, let's take a look at some negative bases. Remember, yesterday we talked about a power is a number such as 3 to the power of 4, where 3 is the base and 4 is the index. And at this point, we are going to be looking at what happens when we have negative bases, such as this one. The question I have to start off with is, do these two questions look the same? This one here and this one here. Now, most students will say they do look the same. But actually, if you check these with a calculator, you will get a different answer. And what I would encourage you to do is to take out your TI-84s for a moment and plug this into the calculator, this one here, this first one. Make sure you are using brackets when you do that, and this one right here as well, and see what you get. With this one, you get 9, and with the second one, you get -9. So we don't get the same answer. And the reason is that what's happening is this problem here, this first problem says to square -3. In other words, -3 times -3. And we know that a negative times a negative gives us a positive, and so we would get +9. The second one says square 3 and make your answer negative. So when you square 3, you get 9, and then you make it negative based on this negative right here, and you get -9. So we get different answers for these ones. Let's take a look at this next one down here. Let's say we have this. This says to square -3 and make your answer negative, or the opposite. I should restate that. Multiply that result by a negative. Let's see what we get for that one. You can try that with your calculators as well. Just make sure that when you plug it in, you are using the negative signs, the brackets, that negative, that bracket, to get the right answer. So if I square -3, that would be inside of here, be -3 times -3, which is now the opposite of 9, and we get -9. So all three of these, this, and this one here, get you something similar. These last two are the same, and the first one was a positive number. It has to do with whether you're squaring a negative number or whether you are taking the opposite of a number. So pause the video at this point to go through these problems, and when you come back, I will go over, you have the answers underneath, but when we come back, I'll go over about 5 of them real quick. So give it a pause. Okay, so assuming you're back now, the answer to this one being a negative times a negative times a negative. This is -1. For B, I have 4 negative 1s being multiplied together, and that is a +1. I'm going to jump down to H right now, where this is cubing -3, in other words, -2 times -2 times -2, and that gives you -8. This one here, I, says I want you to cube 2 and multiply that number, that result, times negative, and you get -8. So this time we did get a negative for 8 for H, and a -8 also for I. And in J, what we're going to do is we want the opposite of -2 times -2 times -2. So if I multiply these 3 together, I get -8, just like I did in H. And then if I multiply that negative here times a negative, I get +8. So hopefully you worked through the others and you did okay. You do have the answers to correct your work. Let's move on to the bottom of the page 1. And let's look at some index laws. And these are really important for simplifying expressions. I would make sure that if you need to go back over this video several times, you do, because we have a tendency to confuse these different rules as we go through them. But I'm going to give you quick examples of each one, and if you want to watch it again, you certainly can. All right, so we're going to look at multiplying two powers that have the same base. Here I have 3 squared times 3 to the 4th, and x squared times x to the 4th. Let's start with the 3's. Okay, and one of the ways that we can see our rules is by multiplying this out in the long way. Okay, I like to call it the long cut. So 3 squared is 3 times 3. We're going to multiply that by 3 to the power of 4, which is 3 times 3 times 3 times 3. Now all of these are just connected with the times symbol, and it doesn't matter if we use a dot or if we use an x. I just simply used an x to say the difference between the 3 squared and the 3 to the 4th. But ultimately what's happening is we have a bunch of 3's being multiplied together. To be precise, we have 6 of them, so it's 3 to the 6th. Let's move on to x squared times x to the 4th. Really, it's the same thing. We don't need to know what x stands for in order to say that x squared is x times x, and we're going to multiply that times x to the 4th, which is x times x times x times x. Again, if you look at this, you have a bunch of x's multiplied together. 1, 2, 3, 4, 5, 6, and so we would say that's x to the power of 6. So we have a shortcut when we're multiplying powers with the same base. This is a shortcut, but when we multiply powers that have the same base, we get to do something with the exponents. Shortcut is 2 and 4 turn into 6. 2 and 4 turn into 6 by adding. So when you multiply powers with the same base, you add the exponents. Very important rule. Okay. When we divide powers with the same base, and I'm going to do the same thing I just did. I'm going to write these out the long way. I have 3 to the 5th divided by 3 to the 2nd. Oh, by the way, this box right here goes on to the second page of your notes, so you can fill it in there. Okay, so now we'll be on the second page, and we're dividing powers with the same base. So 3 to the 5th divided by 3 squared could be written out this way. 3 times 3 times 3 times 3 times 3. So 5 sets of 3, or 5 3's being multiplied together, and 3 squared is 3 times 3. And if I was to divide 5 3's by 2 3's, I could simply cancel out the ones that are in common. Down here we're just left with a 1, and up here we're left with 3 3's, which is 3 to the power of 3. You could go ahead and write that as 27. For our purposes, that will do. And I want you to think about how can you turn 5 and use 5 and 2 to get that 3 right there. We'll do that the same thing with the x's. X to the power of 5 is x times x times x times x times x. I have 5 of them. 1, 2, 3, 4, 5. And x squared is x times x. I'll rewrite that so that little dot isn't in there. X times x. And then the x's can cancel out. 1 gets matched with 1 and another gets matched with another, and we're left with x cubed. Again, think about how 5 and 2 get turned into 3, just as 5 and 2 got turned into 3 with the 3's. And then we can use that to fill out this rule down here. I'll scroll it up just a little bit. No, I won't. It says here when you divide powers with the same base, you can do something with the exponents, and that something is subtract. So we had 5 minus 2 gives us 3. Same thing here, 5 minus 2 gives us 3 with the 3's. You can do that also with other powers, but let's move on to the next rule. Okay, so this now moves to the middle of your second page, and we raise a power to a power. I'm sorry, raising a power to a power, yes. So we have 3 squared to the power of 4. Again, writing that out to the long way, that means I have 4 sets like this of 3 squared. And each one of those sets could be written like this. And again, I'm writing x's in between the 3's, for instance, here, so that you can see that this group represents this 3 squared. But really, times is just times, so this is 1, 2, 3, 4, 5, 6, 7, 8 3's multiplied together to give us 3 to the power of 8. Again, let's look at the connection between taking a 2 and a 4 and turning them into an 8. Think about how you can make that happen. The answer is that you multiply them. So I'm going to use that before I go to this one with the x's, because it's a little bit abstract. So when you raise a power to a power, you multiply the exponents. So let's apply that to x to the power of y, all raised to the power of z. That will simplify to be x to the y z power. I'm sorry, I know some of you would like me to say x to the y times z power. That works as well. Okay, so there's our third rule. Our fourth rule is finding the power of a product. That's our fourth rule for today. And that's where I'm taking a product, in other words, 2 numbers multiplied together, and raising that to a power. And again, if I were to write that out the long way, I would see 3 times 5 times 3 times 5. And what we can see happening is that there are 2 3's multiplied together for a 3 squared, and 2 5's multiplied together for a 5 squared. We could multiply that out if we'd like to get 9 times 25, but for our purposes, again, we'll just leave it like this. We can do this again with the xy raised to the power of 2. And in this case, if I were to write it out the long way, it would be xy times xy. Again, showing us we have 2 x's being multiplied together and 2 y's being multiplied together. So before we go on to this third one, let's look at our rule. When you raise a product to a power, what do you do with the exponent? I think it's important to note that both the 2 went to the 3 and to the 5. That happened here as well. Both the x and the y received that 2, and that's called distributing or expanding. So let's just fix that. When you raise a product to a power, you distribute the exponent or expand the exponent. And we'll do that here with this xy to the power of z now. And that will be x to the power of z times y to the power of z. No, we don't know what the z stands for at this point. If we did, we'd be able to simplify it some more. Okay, moving on to the next screen. You have a series of problems here. I'd like you to pause the video in just a moment and try to apply the rules that we had from the previous one. Actually, I'm going to do these ones for you, and then the next slide you can do on your own. So here I have x to the 3 times x to the 4. The rule that I'm going to apply is I'm multiplying powers with the same base, and so I add the exponents, and that's going to give me x to the 3 plus 4. So I'm looking for x to the 7th, which is right here. So that y and 18 go together. Okay, 3x squared times x, I need to think about that having an invisible 1. The 3 is just going to be a 3. X squared times x. Again, I'm going to add my powers together, my indices, and I'm going to get 3x to the power of 3. Do I have that over here? Yes, I do. It's this one right here. So that's number 3. For O, I'm going to multiply the 2 and the 3 together to get a 6. Again, think about an invisible 1 right here. I'm multiplying 2 powers together with the same base. So we add the index. So x to the 2 plus 1. And we get this one right down here. So that's number 26. Here again, I have an invisible 1. I'm going to add 1 plus 2 plus 3 to get x to the power of 6, and that's number 7. So x to the 1 plus 2 plus 3. So that's 7, x to the 6th right here. Okay, here I have x to the 4th times negative 3x squared. The negative 3 is going to come out front. There are no other numbers to multiply it by. I'm going to add 4 and 2 because I'm multiplying powers with the same base. Get negative 3x to the power of 6, which is right here. Negative 2 times negative 2 is 4. We have an invisible 1. Again, I'm going to add 2 and 1 to get 4x to the power of 3, which is right here. And the last one on this slide, we have a negative times a negative is going to give us a positive. That has an invisible 1. There's 1 and 4 and 4, so it's x to the power of 9. There. And that's number 11. So I would encourage you to pause the video for just a moment and work on these problems, and then I will give you the answers. Okay, so welcome back. I hope you did pause it and aren't just going to copy it. I'll give you the answers. It should go H, E, G, E, T, S, S, P, L, I, N, T, and E. And some of these, there's double E's and double S's and double T's. So let me show you the right ones that they go with. This one right here is x to the power of 12. This E right here is 16x to the 6th. And that is E, this one here. Okay, one of this T right here is negative 27x to the 12th. This T right here is 5x to the power of a lot. No, 125x to the power of 11. Number 6 should go with the 64x to the 10th. This S here should go with negative 32x to the power of 15. And this E right here should be negative 64x to the power of 4. Where's that one? Right there. Okay, so you can check those answers. And we're going to move on to the next slide. We're nearly finished here with the video. So if I was going to, this gets a little bit complicated, but if I was going to express these in simplest form using a prime number as a base, I'd have to think about composite numbers and turning them into primes. So for instance here, that 4, that's not a prime number. I have a 9 here and a 49 here, and neither of those are prime. So let's think about how we can get 4 from a prime number. Well, 4 is 2 squared, and I'm going to raise that to the power of 4. So now I can use my exponent laws, or my index laws, to say that if I raise a power to a power, I multiply the exponents, and that will be 2 to the power of 8. For this one here, the 9 is not prime, so I'm going to write it as 3 squared, being multiplied times 3 to the power of a. And remember, oh, let me write that so it looks like an a, not a 3 or a 9 or something. Okay, if we multiply powers with the same base, we keep the base and we add the exponents. So a plus 2. Let's see, here I have 49, which is not prime, but it is 7 to the power of 2, which I want to write as x plus 2. Now if I raise a power to a power, that means that I multiply the exponents. So I write it like that, which I can further simplify by distributing there to get 7 to the power of 2x plus 2. All right, we've got a couple more here. I'm going to ask you to pause the video so you can answer these, and then I will give you the answers. And I think that in doing this we have a little bit of a technology glitch, so we're not going to do this one. And this should have a little space here of 25 squared being one problem and 4 times 2 to the power of x. Okay, so pause it again. Okay, so this is going to be 5 squared squared, which is 5 to the 4th. This is 2 squared times 2 to the power of x, which is 2 to the power of x plus 2. Okay, almost there. So with these problems here, we can use our calculators to get the answers to these. Again, pause it, and just practice using your calculator to raise to the power. With your TI-84s, you're going to use that little caret. It looks like that, and it's right above your adding, subtracting, multiplying, and dividing keys. Okay, so pause the video, use your calculator for a moment. And welcome back. 512, negative 3125, negative 243, 16,807, 512. I'll erase this. And this one, 6,561, negative 6,561. And here we get a lot of decimal values. So I just wrote out all the decimals that I see on my computer or calculator display. 117264691. This one is negative 0.7644799564. This one is negative 20.36158496. Woo! Okay, from here on out, starting with number 1, 2, and then turning the page 3 and 4, you have plenty of practice problems you can do, and at the bottom of the 4th page there are answers. You can move on if you're looking from some extra challenge to the last page. Those are some optional that you can do. What I'd like for you to do as an assignment is to finish up this packet. Of course, if you don't want to do the extra challenges, you don't have to. Our objective today was to use exponent laws to simplify powers and to learn to use our calculators to solve expressions. I hope you feel somewhat confident in them after watching this video and doing the practice problems.